Record.
Yeah, comes on everyone. Let's start off. So last time we did the trajectories. Let's see a question. Energies and everything. Yeah, hope everyone mucked up the formulas here. So let's see. Two satellites revolve at an altitude. Others scans on. Of 2R and 3R. With masses m and 2m. Find ratio of time period, velocity, total energy, angular momentum, get this for. So we have two satellites revolving at an altitude of 2R and 3R with masses m and 2m. Find the ratio of time period, velocity, total energy, and angular momentum. Why so many people are missing? Hmm, 16:27. Let's see. First one, the time period we know t square 2 pi root gm r to the power of 3 by 2. Remember, this m is the mass of the planet, not mass of the satellite. Don't mess it up. That m is the mass of the planet. So T1 by T2. दूसरा second thing, he said altitude of 2r. Altitude means height. That means these distances are actually, one guy is going at a distance of 3r and the other guy is going at a distance of 4r. Be careful, altitude and distance from the center are completely different. Altitude is height from surface. If you take 2r and 3r, you'll get wrong answers. Because in the formula, smaller is the distance from the center. So T1 by T2 will be 3r by 4r whole to the power of 3 by 2. So 3 by 4 whole power 3 by 2. That's your time period. Velocity root gm by r. V is proportional to 1 by r. So V1 by V2 will be 4 by 3 whole to the power of 3 by 2. Third is energy. Energy is minus gmm by 2 times small r. So this is also proportional to 1 by r. So E1 by A2 will be 4 by 3 whole power 3 by 2. Angular momentum is mvr. So V is proportional to 1 by root r and this is r, so proportional to root r. So L1 by L2 will be 3 by 4 whole to the power of half. Please check. Sorry, 1 by root r, na? My mistake. Check your answers. It is just all formulas. I'm telling you again. If you know your formulas and results, you will be able to handle 60 to 70% of the questions. Most people go for because you don't remember the formulas. Altitude means height from the surface. That is the meaning of altitude. If I say radius of the orbit meaning it's the distance from the center. So if someone says the radius of the orbit is 2r, means he's saying you distance from the center is 2r. If I say altitude 2r, altitude is always measured from the surface of the planet. So it is r plus 2r. Clear? Energy E1 by E2 is 4 by, right, it is 4 by 3. Why the hell am I putting roots everywhere? Yeah, I wrote it wrong. C is wrong. I don't know why. I kept a root somewhere for some reason. Clear? Got this? Easy. Next one. So we have a rocket which is going in an orbit of radius r. Radius, let's say 2r. Now see, this is the radius of the orbit. Altitude is r. This is going with some speed u. So the rocket thrusters, so this satellite, whichever it has some rocket, so the rocket thrusters give an additional speed v opposite to the direction of thrusters. So whenever you switch on the thrusters, right, you can switch it only for like a few seconds. So in that few seconds, right, it gives you an additional velocity v opposite to the direction of thrusters. So what you did, case 1, You are going with speed u. You gave an additional velocity in this direction, plus v. Case 2, your rocket is going this way, and you kept the rockets towards the earth. You gave the velocity v this way. You getting the difference? You can keep the rocket ka thrusters in any direction you want. In case 1, the rockets were switched on. So gas came out this way, the rocket went faster in the forward direction. Case 2, the rocket was looking like this. So the gas was ejected this way and the rocket got velocity away from the center. Got the catch? You're getting the 2 cases. So basically in case 1, the rockets give a tangential velocity. So tangentially you increase, so basically speed ho jayega u plus v. Gives tangentially, here rocket gives radially, matlab away from the center. So whenever you switch on the rocket, you get a speed v. Now that v you can give in any direction you want. So the question is, find the maximum distance from the center of the planet. Find max distance from center of the planet. Just get the equations. Numbers are bad. It's all u and v, all variables. Just give me the equations and sufficient. I hope the question was clear. If the rockets are not switched on, what will happen? You'll go in a circle. When you switch on those rockets, something will happen and this will create some issues. Exam, I can ask you this question. Find v so that it escapes to infinity. We can ask a lot of things. Shaurya.
Sir, it is going in circle due to that gravitation and centrifugal.
Yeah. So satellite orbits in a radius of in a radius of 2r. Then you switched on the rockets. Case 1, the rocket gave an additional velocity tangentially. Case 2, the rocket gave velocity radially. In both the cases, find the maximum distance of the rocket from the center. What are the steps? Once switch on the rockets, do you think it will go in a circle? It will not go in a circle. It will go in a curve, right? Some curve. If you go in a curve, what did I tell you? Conserve angular momentum. Okay. But if it is going in a curve, you don't have anything else to do. Conserve energy, conserve angular momentum. You don't have anything else. You don't have any other way of solving this kind of problems. I'll help you with the first one. Yeah, case 1. So basically the speed became v plus u. So this guy will actually go in some kind of path like this. This is your maximum distance. This was 2r. At the farthest point, the velocity will be perpendicular, right? Yeah. Let this be smaller. Initial energy will be half mv plus u whole square minus potential energy minus gmm by 2 times radius. Don't forget, energy of a satellite is minus gmm by 2 times radius. Here radius is 2r. Is equal to final velocity. Let's call this guy v dash. Half mv dash square minus gmm by small r. That's your energy conservation. Then angular momentum conservation, m v plus u into 2r is equal to mv dash into small r. So when you solve the two equations, we get a quadratic. We get a quadratic in R. So if we get two roots, what does it mean? If we get two roots, one is minimum distance and one is maximum distance, basically ellipse. What is one is minimum and another is maximum distance. Means it is going in an ellipse. What if you get imaginary roots? What if you get imaginary roots? This implies particle escape to infinity, no? There's no minimum distance. It has gone to infinity. The velocity is so high, you just went off to infinity like this. You become a hyperbola. Got it? So maximum distance does not make sense. No, maximum distance is infinity. Getting it? So particle escapes to infinity. So there's a max way of saying what you're asking is not possible. What did you ask? Find the maximum distance from the center, which is infinity. Got it? So I could ask you like that question also in the exam. Find that additional thrust that has to be provided so that it escapes to infinity or escapes the planetary gravity. Got the idea? Can you do for the second case now? Same thing. But this time you gave the velocity v radially. So the second question, you are going like this. This is u and this is v. Just get the equations. Distance is 2r. Everything is same. Now you try the second part. We'll finish off gravity in the first half and then we'll start with Gauss laws today.
So that JMM upon 2R is the total energy of satellite.
That's the total.
Energy.
You're right. No, nahi likhna tha actually. JM by 2R only. Because kinetic energy I took it separately, no?
Right.
That's a mistake. I shouldn't do that. This is only potential energy only. You should not write total energy because kinetic energy you have taken it separately. That was a mistake. I think I'm sleepy, I guess. I'm doing a lot of mistakes today. Let's. When is the test ka deadline, right? Friday, no?
Yes.
Everyone make sure to give it. Ray optics and rotation. After that, next week, you will have a full syllabus का एक test होगा. मतलब kinematics, NLM, friction, circular, work power energy, rotation, center of mass, fluid dynamics, SHM, thermodynamics. Major test आ रहा है ना in 3 weeks for PACE people. So it will be a good revision. Very so surprised. Final exam, you have more topics. Right? You have all the topics in the final exam. You can't get scared with only this many topics. If you don't write, then you'll never be ready. At least if you write, you'll mess up in my exam. What to do for this, guys? Fast. I'll give you a minute.
Sir, all is same. Just it came under root v square plus u square.
एंगुलर मोमेंटम भी चेंज होगा रे.
हाँ बस मतलब वही अंडर रूट v square.
So this guy will be u, this guy will be v. So this will have a velocity like this. So this also will go in some kind of an elliptical path. This is the maximum distance v dash. This is r. This is 2r. So when you conserve energy here, kinetic energy will be half m v square plus u square root over v square plus u square ka square na. Potential energy is minus gmm by 2r. Half m v dash square minus gmm by r. So can you tell me which one will be bigger? Case 1 or case 2? Which will be the farthest point?
Second or first one?
Think in the case of energy terms, can you see this? They look same, right? Only this term is different, no? So which one is bigger? V plus u whole square or v square plus u square?
Plus whole square.
V plus u whole square.
Whole
No?
square. Yes.
So that means you're giving, so by putting a rocket in the direction of this thing gives you more energy actually than putting in any other direction. So you can actually extract more energy from the rocket by giving velocity always in the same direction. So when you solve this, you get a quadratic and solve the quadratic. You'll get the answers from here. Clear? So normally whenever they launch rockets, right, to far off, out of the space or something, this is the technique they use actually. So let's say you launch a satellite, you launch a rocket or something, and you put it in some orbit. So using rocket thrusters and all, you can put it in an orbit like this. It will be going in some kind of ellipse. Okay? This is still not good. So you like to actually keep it as close as possible. Yes, okay. So now your rocket is continuously going in this elliptical orbit. Aisa. Now the rocket ka fuel is limited, right? Rocket ka fuel is limited. So you can switch on and switch off the engine certain number of times. So every time you switch on the engine, you're going to consume some amount of fuel. You're getting it? So the number of times you can switch on the engine or the amount of time you can keep the engine on is fixed. So these people came up with an idea. Now see, the point is this. Here energy is not conserved. What is conserved is whenever the rocket is on for some time. Remember the thrust force ka formula we did in this thing? Variable mass system. What is F thrust force? U into R. Remember where R is the R kgs per second gas released and speed is U relative. This is constant, isn't it? So every time you switch on the engine, the speed will be, gas will come out with U and the R is the rate of emission of this thing. So force into small time dt will give you change in momentum. Agreed? So the additional velocity you get will be UR, T will be M into the change in velocity. So change in velocity will be URT by M. So this is that additional velocity you can always give whenever you switch on the engine for a certain time. So the question is this. When you're going in an elliptical orbit, at which point should you switch on the engine to get a maximum boost? If you want to send the satellite farther and farther from the planet, at which point should you switch on your engines so that the rocket will it'll go much farther? You want to escape from the Earth and go to some other planet like Mars or something.
Tip of the ellipse?
Where? Which ellipse?
Like
there are 2 points, na? Yahan pe?
Yeah.
Yahan pe where? Closest point, the farthest point?
Sir, closest point ना, because उस time पे जो होगा वो perpendicular हो जाएगा तो.
Farthest.
Why farthest? Why closest? See, I'll just tell you something. Let's say every time you give an addition, whenever you switch on, additional velocity आएगा 2 meters per second. Agreed? So what will happen to the kinetic energy? आपका kinetic energy हो जाएगा half mu plus 2 whole square ना. So if you want to get maximum kinetic energy, you should be what? More or less? More.
More.
At which point is the velocity maximum? Angular momentum mvr is constant na. So v is proportional to 1 by r, right? The closer the point, faster it goes. So if you switch on the engine at this point, when you are the closest, so the first time when it comes, something interesting happens here. So first time when you come, the speed becomes v plus delta u. Because of this additional speed, this guy will go in another elliptical orbit. But because you started from there, you will always come to the same point, isn't it? You started there, it's a closed orbit, na? So wahi pe compulsory aana padega. Second time, again, when you come here, exactly switch on the engine again. So v plus 2 times delta u. Now you'll go in a bigger orbit. You getting it? So you keep on switching on the engine whenever it comes to this closest point. At one point, you're given so much velocity, you go to infinity. Got the idea? मार्स मिशन में यही लॉजिक था. वो मंगलयान मूवी देखा?
Yes.
कौन था वो? अक्षय कुमार का. This is the made the whole movie on this concept. And Blady didn't explain anything. किसी को समझ में नहीं आया what the hell is happening. But this was the idea behind that whole mission का concept यही था. So you can actually, but this will take time. Every time it comes, you have to precisely keep on switching on at this position. So you will gain maximum amount of energy for a given thrust. Is this clear? So there. Next thing, Kepler laws. So this guy Kepler, right, is actually not a scientist. He's a mathematician. So near his house, there is a big observatory where they had data for almost 130 years. Got data of all the planets and sun and everything. The thing. So this guy took out all the data and started doing calculations, and he figured out few laws. So from that data, right, he gave you all these laws actually. He never did any experiments or anything. It's all maths. So if you see, actually, Kepler is the data scientist. He didn't do any work. He just took out all the maths, and from there he figured out stuff. So all planets revolve around the sun in an elliptical orbit. With sun at one of the foci. And I hope you remember the properties of an ellipse, which I taught you in thermodynamics also. This is your semi-major axis. This is your semi-minor axis. Equation is x square by a square plus y square by b square is equal to 1. And the area is pi AB. So this is the first law. It simply goes in a ellipse. The second law, the area swept by the radius vector is equal in equal intervals of time. Meaning, if the sun was here, let's say in time t, you have traveled from A to B. And in another time t, you have traveled only from C to D. Because you're farther, you're going slower. So what this law says is the area of SAB is equal to area of SDC in equal time. So this thing is actually right. If you take the sun here, if this is your r bar, in small time dt, let it travel a distance of v dt, you get a small triangle. Anyone remember the area of a triangle formula in vectors? Half a cross b, the two sides basically. So it will be half r bar cross v bar dt. So this will be small area dA by dt will be half r bar cross v bar multiplied and divided by mass. This becomes angular momentum by 2m. This is a good result. So aerial velocity, that is the area covered per unit time, will be dA by dt, which is nothing but L by 2m. Got this? This is one important result. Direct question this. So if someone asks you time period, how will you can calculate? Time period is nothing but the total area by aerial velocity, right? So that will be pi AB, that is the area of an ellipse, by L by 2m. That's how you can find the time period also. Clear with the first law? Check out the second law also once. This is a good one. So a simple question, right, will be like this. The Kepler's second law is another form of what? It's actually another form of conservation of angular momentum. We will prove that in the next page. This year bits ka cutoffs will go down. Only 13.5% in Maharashtra got 75% and above in HSC boards. Why did it happen? Because people are idiots. At least your seniors, some of them are really idiots. Even after telling them n number of times to start studying, they never took things seriously. And अभी इसका मतलब ये नहीं है अभी HSC का preparation start करो. HSC if you start preparing even in December, it's enough time. But problem ये हो गया था because these people didn't take studies seriously. Once the portion got over in November, right? They didn't have time. You know, exam is in Jan second week. Boards is in Feb second week, Feb third week. So either you can study for JEE mains or you can study for boards. People became a little overconfident. हाँ मेरा boards हो जाएगा, and that's messed up. So what is the story for you in this, guys? If you prepare now properly, mains thoda ho jayega, so we'll have time even during December and Jan for boards. If you don't study now, everything is gone case. So please continue working. All I'm asking is whatever I'm teaching you, be parallelly do with me. Give all the exams I'm conducting sincerely. Itna karo, your physics is taken care of. Aram se, if the JEE paper is like last year, this year 2023, you guys will aram se score 80 out of 100. Aram se you'll score. If the paper is like this year or last year ka paper. But for that, you need to get all the work done. So this thing, what is happening now? Because 283 out of 390 bits go over CS, right? Difficult nahi hai ye. I have my mains ka batch, okay? Only main students. We don't even prepare them for advance. At least 5 to 6 of them out of 15 people, right, scored at least, you know, some people scored 260, highest was 316. Sirf mains tha. Advance bhi nahi tha wo batch. हाँ, JEE mains they messed up, but bits they did quite well. 283 में bits go over CS. I think 270 or 280 में you're getting bits Hyderabad CS. I'll post the cutoffs in the group later on. You can see it. Bits Pilani CS was 320. Third or fourth round. First round में नहीं आएगा, but 320 cutoff. This year so far, one of your senior got 346. But anyway, advance is the main thing, which is just a backup. But it's still good. So I'm telling you seriously, put effort. Next year, sitting and crying, kuch matlab nahi hai. Take this thing very seriously. And I'll tell you one thing from my personal experience. It is either 0 or 1. There's nothing in the middle. Means if you're studying, it is only studying. If you're trying to balance, right? If you want to balance your entertainment and study, wo nahi hoga. Some of you are still trying to do that. Every day I will study for 3 hours, then 1 hour I'll sit and do entertainment. Nahi hota hai. I think you're at a point where, you should just forget about all entertainment, leave everything. In your life, you have only study, or you're sleeping, or you're eating. Bas ho gaya. That's it. There's nothing else in life for you, at least for the next 6-7 months. If you can prepare that way vigorously, I think you will easily get it. Easily, ye to difficult hai. But if you're trying to do everything right, I will have some entertainment. May har roz 1 ghanta, I will watch YouTube. Then I'll try to study 2 to 3 hours. Nahi hota hai. You won't get disciplined. You leave everything and then you start doing. I'm telling you, it will be a breeze for you. I think that is what you guys are missing. It should be a commitment, matlab, nothing else in life. It's like a single focus. You will just study every day. Once in a week, Sunday or any day that you get a break, take a day off. For a half day, you can take it off in a week. But I think you should study. Sir, but I will burn out. First burn out, na? First burn out. Then we will see. You're getting it? You are starting only, you start feeling it. Oh, if I do like this in a week, I will burn out. Okay, na? Burn out in a week then. First you burn out, then we will see what to do. As simple as that. So don't, put a limitations on yourself. Who can do like this? I'll show you hundreds of people doing like that. I'm sure there is one person in your house who's doing it, your dad or your mom. Ask your dad, when was the last time he got a vacation? They don't get holidays like you. You don't see him, right? After the office work, he must be tired. 9 to 10 hours office and 2 hours in the train getting free massage. Then, even if he's coming in traffic, so 2 hours in traffic. Kuch difference nahi hai. Just follow the instructions, listen, don't leave me till the last day. Leave me matlab kuch nahi hai. I'll just keep posting in the group, I'll keep telling you what to do till the last day. Some idiots just ignore it, I don't know why. They don't do the work and they feel shy to come back to me. I don't know what to say. After everything gets messed up, then the parents call me and ask me, sir, abhi main kya karu? Abhi kya karenge? Kuch nahi karenge. Can you imagine there is an idiot who didn't apply advance ka form fill nahi kiya tha? Advance का फॉर्म फिल नहीं किया, हो गया, ठीक है. There is another idiot who didn't apply for MIT and VIT. मैंने पूछा क्यों? नहीं सर, मेरा JEE मेंस हो जाएगा. I said first JEE मेंस में कितना आया था? 82 percentile. I said on what basis 82 percentage नहीं, bloody on what basis 82 percentile you are hopeless? On what basis you thought MIT VIT हो जाएगा? He didn't apply. People come for advice. They listen. Then they do what they want. Then why the hell do you ask for advice? ये हर दिन का स्टोरी हो रहा है. Last I think 1 month से यही स्टोरी. Every day someone calls up. Some people tell good news, some people say bad news, but there is one idiot. उसको bits में आया था 290, 75% कट ऑफ क्रॉस नहीं किया. पता है उसको कितना बोला था बोर्ड्स पढ़ो. Simple रहे, HSC के लिए I'm telling you something again. You need not worry much about it. December से we start the preparation. I'll tell you what I told your seniors. I'll tell you the same thing. We came to know JEE mains will be in January by November end. Getting it? We didn't know only. Everyone is assuming exam hoga April first week mein. First attempt. That was a big surprise for us. Luckily for you, surprise nahi hai. Jan first week exam, Jan second week is exam. So we came to know JEE mains exam is in December first week almost. So we had around 1.5 months. and Feb, third week is a board exam. So college ka prelims, everything will happen in December only. So I told them from December 10th onwards, every day 1 hour ka HSC study. That's it. Every day 1 hour. 1 hour ka HSC, 9 hours JEE preparation. 10 hours per day study. Because you don't have any classes. There are no new chapters. Kuch bhi nahi hai. Other than sitting and studying, there's nothing to do. We need to do this till Jan 2nd week. Till your JEE exam gets over. When the JEE exam gets over, you have to give 3 HSC ka prelims. All subjects prelims. Matlab you have to sit and write a paper for 3 hours properly. You just have to study from HSC textbook and target ka guide. Target or Navnik. Bas ho gaya tha. With this thing, many of your seniors scored 90%. 90% on HSC. Aram se. People are just lazy, pata hai? After telling them 10 times to write the paper, can you imagine I conducted HSC ka sessions for your seniors? I didn't do it. I called up some teacher who does for HSC, extra sessions. I paid him. I arranged 4 sessions for them. Which chapter, what to do, how to write. Itna karne ke baad usme bhi 10 students bunked the class. So that's what I'm saying. Idiots. वो 10 में ये एक था जिसको 292 आया था बिट्स में एंड HSC का इसका 71% था. Disqualified idiot. बिट्स गोवा का सीट गया. बस इतना simple instructions, people don't listen. I don't know what they think.
Same boards, they aren't second attempts like how they were in 10.
Second attempt मतलब?
मतलब first बार कोई reason से किसी ने नहीं दिए boards, तो
Then there is something called supplementary, no? You can write them, but that will be somewhere in July or June. By that time, all the exam ka counselings will be over. Then you have to wait for next year for again entrance exams. So you lose your 1 year. So you're planning something like that. इतना बड़ा planning कर लिया रहना.
नहीं sir, just doubt था.
मैं कुछ बोल रहा हूँ, पढ़ाई करो and take a plan. Sir अगर extra exam दे देंगे तो हो जाएगा क्या करके? You guys are gods रे. Instead of saying okay चलो prepare करना है वो नहीं है. चलो मैं fail हो जाऊंगा अभी क्या करना है? बहुत future planning है. चलो anyways let's get back to this. No, because this also your seniors asked. वो जो 71% आया था ना, he came and asked the same thing. Sir, I'll give supplementary, I'll get more marks and उससे हो जाएगा. Bullshit होगा. Which people don't care. When the day the counseling happens, you need to submit your form, how much percentage you got. If you can't submit on that day, you're disqualified. ये हुआ था 2 years back during COVID time. Physics का board exam ना, when it got over, physics का paper का correction time में teachers did a strike. पता नहीं क्या हो गया. Everyone messed up physics. People got very bad marks in physics. 29 out of 60, 75 बहुत कम आया था. So there were 2 students. One guy lost the bits ka seat with 3 marks. Another guy lost a bits ka seat with 7 marks. Cut off. दोनों को bits को हुआ, bits plan मिल रहा था. These both of them applied for revaluation. Revaluation का result का date was June 26th. Bits का counseling date was June 19th. These people called up bits and requested them. 26th को result आएगा. We are sure. Please do something. They said we are a private college. We don't listen to anyone. We don't care. 19th tak, if you can produce the certificate that you scored 75, we will do. Or else we are gone. June 26th result आया था. This guy physics का marks went from 29 to 52. Getting it? इसका भी कुछ बढ़ गया था marks actually. इसका मुझे याद नहीं है, but at least 12 to 15 marks increase हुआ था. Both of them became eligible for bits. Counseling खत्म हो गया. One guy joined in Sardar SV, you know, this Sardar Patel College CS. दूसरा, I think he went to Manipal. Then they cry, sir, it is unfair, it happened like that. I said, first of all, cut off 75%. If you had scored 90 percentile or 85 percentile, उसके बाद marks कम हो गया तो 80 आता था. Why the hell did you first of all only get in the border range? वो तेरा fault है पहले. You getting it? You don't think that way. You keep blaming HSC वाला ऐसा किया, HSC वाला ऐसा किया. अरे idiot, then you should have aimed for 85 ना. तो अगर 85 aim किया तो प्रॉब्लम नहीं होता था. You should have kept 10% buffer. Anyway, let it be. Afternoon यही story चल रहा था, 71% वाला. I think that's why I'm telling you guys. Listen till the last day. I am not leaving it till the last day. You guys leave me, so I can't do anything. You just need to follow instructions, do the work, and you be as sincere as possible. Help चाहिए तो teachers are always there. But again, I'm telling you, all of you should get into good colleges. NIT, BITS, triple ITs, Vellore में computer science, Manipal में computer science. Vellore, Manipal में बाकी branches इतना कुछ ही नहीं है. Minimum, this is a bare minimum. Someone is preparing well, advance भी जाना है. Girls have 20% reservation. Difficult नहीं है. So what I'm saying is the worst case scenario. Your first target should be IITs only. उसके बाद BITS, NITs. BITS में तो you guys have a very good chance. IITs का एक ही प्रॉब्लम है. You might get into the second tier IITs, but ठीक है, still IITs. We don't know. But like I said, right, अभी the current situation, the way you guys are going on, advance is still little far. Once you prepare for mains and do well, then advance का preparation start करते हैं first attempt के बाद. But before that, you need to score 180 out of 300 in JEE mains. ये आपका target होना चाहिए. I think if you can get this much in JEE mains, ना BITS भी crack हो जाएगा. Work towards this goal. 60, 60, 60. 360s. Means think in the other way. Means you can leave 40 marks. Meaning even if you don't know few chapters, chalega. But whatever you know, you should know properly. So keep this in mind and study. Electromagnetism, modern physics, wave optics. What else is left? जो fluid mechanics इतना बचा है, all this together is around 50% weightage physics में. So whatever is still left over is 50% weightage. So we can still do this. So please take this thing seriously. So gravitational force here is always towards the center. बहुत गुस्सा आया था उस पे आज. What to do? No, I can't shout on him also. What will you shout on him? Idiot, I told you. He is already crying, he failed. I was getting angry on one side because he didn't listen to me. अरे उसको literally पता है. I called him 3 times before the board exams and told him, boss, to attend नहीं कर रहे हो, boards prepare नहीं sir हो जाएगा, आप tension मत लो. That is where I'm getting pissed off. 3 times I called him and told him. 292 रे, BITS गोवा का CS का सीट है. अभी now this idiot will go and join in KJ Somaya. Idiots. So torque about sun is 0. Therefore, angular momentum about sun is constant. And remember, we got the aerial velocity, dA by dt, which is nothing but L by 2m. This is also constant. Since L is constant, this is also constant. Therefore, Kepler's second law is another form of conservation of angular momentum. They do ask this kind of questions in CET. Bernoulli's equation is another form of what? Conservation of energy. The equation of continuity is another form of what? Conservation of mass. Kepler's second law is another form of conservation of angular momentum. Clear? Have a look at this. Second law is important. The aerial velocity का formula. And this is another form of conservation of angular momentum. Next thing. Kepler's third law. The time period of this orbit is proportional to semi-major axis का cube. So t square is proportional to a cube. So exam mein na, they asked a question like this in mains. They said there are 3 orbits, one circular orbit and 2 elliptical orbits. This is orbit 1, orbit 2, and orbit 3. All of them have same major axis, 2a. So B is changing for all of them. So the question was this: who has more time period? Time period is same for all. It depends only on A. It does not depend on B. So the formula for the time period now is 2 pi root over gm a to the power of 3 by 2. This is the same formula which you have in circular, but A is the semi-major axis here. So the formula is same for ellipse and circle. Circle ka case mein A is R, for ellipse ka case, A is the this thing.
So that satellites was in a circle.
Yeah, satellites go in a circle. Satellites can go in elliptical orbit also.
But the formula we derived was for circle.
So that is valid for this also. Circle ellipse के लिए same formula है. But वहीं पे radius है ना, यहाँ पे A radius नहीं है. A will be what? Semi-major axis ना. ठीक है. The third question was this: who has more energy? This we will prove later on. Energy of an elliptical orbit energy of a satellite in an elliptical orbit is minus gmm by 2a, where A is the semi-major axis. So energy is also same. So doesn't matter whether you take a circle or you take an ellipse, as long as the semi-major axis is same, time period is same, and energy is same. Why is that? Energy we will prove later on. But it's a pretty good question. Have a look at this. Let's see a few questions on this. Clear?
Sir, 1 second, can you show that? Yes, sir.
Let's see this question. So we have a satellite going in an elliptical orbit.
So that big M was of the sun.
M is always the mass of sun. So we have 4 points here: A, B, C, and D. So, and it is going this way, the satellite is going like this. So first thing, compare time taken. So the time taken from A, time taken from D, A, B, time taken from B, C, D, which is greater, which is equal. Second thing, work done by gravity. So when this guy is going in elliptical orbit, what is the work done by gravity from A to B, B to C, C to D, and D to A? You should just tell me whether it is positive, negative, or zero. How to do this? So a satellite is going in an elliptical orbit. Which will take more time, DCB or BCD, or the times are equal? And when the satellite is going from ABCD, what is the work done by gravity from A to B, B to C, C to D, and D to A? Is it positive, negative, or zero? Okay.
So
Think it's a
BCD,
good one. Sarah?
BCD is more because distance is more, so speed will be less.
Think. I'll give a minute. It's a good one.
B and B form the minor axis of the ellipse, right?
BD is the semi-minor axis.
Time taken is equal.
Show you. PCD is more. You guys are actually getting confused at one part. The area swept by the radius vector. So the radius vector starts from where? See. So this is the sun. This is D. This is C. So this is the area, right? Isn't it? Area swept by the radius vector, matlab, when you say area BCD, this is the area, na? When you say area from DAB, this is the area, right? Which area is bigger?
Red.
Red one. So area BCD is greater than. So mistake you're doing, you're taking area from the center, na? It looks equal. Area should be measured from the sun. It should not be measured from the center. Look at the statement here, how we draw the diagram. See, where did you take the area from? From the sun, I draw to the ellipse, isn't it? It's not from the center. So be careful. Most people think it is equal. So area taken from BCD is greater than area from DAB. Therefore, time from BCD is greater than time from DAB. Easy? What about
Sir,
work done?
Momentum also, ना मतलब वो distance बढ़ा रहेगा तो velocity कम.
उसके बाद क्या बोलोगे मतलब?
So in the part B,
it is not linear functions, रे God. कुछ linear नहीं है. You can't directly say like that. You can't say. You know क्या? These distances and all. Now what about this thing? You can still say actually speed का.
Sir, at point C and point A we can tell, no? By angular momentum.
इतना बोल सकते हो. Yeah. From there you can guess actually. What about work done, people? A, B, B, C, C, D. Any guesses? See now, what is work done by all forces?
Change in kinetic energy.
Change in kinetic energy. So here it is only gravitational force. Here it is only gravity. So when you're going from A to B, is the speed increasing or decreasing? Work done from A to B, is speed increasing or decreasing?
Decreasing.
So VA is greater than VB, right? So speed increased, no? Speed actually decreased. So work done from AB is negative. Change in kinetic energy, your speed is decreasing. So VB is greater than VC, then work done in BC is also negative. Is that making sense? Since speed is decreasing. If the speed decreases, kinetic energy, change in kinetic energy is negative. Means gravity is taking away energy from you. And then again, VD is greater than VC. The work done from C to D is positive. Again, VA is greater than VD. Work done from D to A is positive. If someone asks you work done in the full cycle, A, B, C, D, A, it is 0. Conservative force, work done in a closed path is 0.
So, but we won't take gravitational potential energy between satellite and sun.
Work done by gravity is only potential energy. Potential energy and work done by gravity are not different. If you use potential energy, don't talk about work done by gravity. Is this clear, everyone?
So
Next one.
Speed at A and C is highest. No?
क्या बात कर रहे हो boss? Speed at A is maximum, speed at C is minimum.
Yeah.
Clear? Any doubts on this? It's a good one, right? Simple question, not tough, but it's a good one. Next one. This is a good one. This is like a theory and a problem. So we have a satellite here. So sun ka mass is m. And we have a satellite going in an elliptical orbit. Let this distance be r1, let this distance be r2. So at this speed is v1, at this point the speed is v2. So this is point A and this is point B. A is the closest distance. It's also called as perihelion or perigee. For sun, it is called perihelion. So this is the farthest point. It is called as aphelion. I think for moon, it is called apogee. So in this question, we know R1 and R2. So the question is first one, find V1, V2. Second thing, find aerial velocity. Third, find total energy of the satellite. Time period. Length of the minor axis. Radius of curvature at A and B. Find eccentricity of the ellipse. This would be like a proper advanced paragraph question. You can ask a lot of stuff in this. Eccentricity is actually easy. But anyways, try, get the first one. If you got V1, V2, you'll get everything from there. Try, I'll give you 3-4 minutes, then I'll show you. Just give it a try with some water and come. Let's see. See, first thing, like I said last time, the only thing you can do for an ellipse is conservation of energy and angular momentum. So V1, R1, V2, R2. Angular momentum conservation M V1 R1 is equal to M V2 R2. So V1 R1 is equal to V2 R2. This is the first equation. Then energy conservation minus GMM by R1 plus half M V1 square minus GMM by R2 half M V2 square. So take V1 from here and substitute here. M goes off. V2 square, R2 square, R1 square, V2 square by 2. So this is GM 1 by R2. So R2 minus R1 by R1 R2. This side V2 square by 2 common. R1 square minus 1 by R2. It was coming. R1 minus R2. This will be R1 square minus R2 square by R1 square. So V2 will be 2GM. R1 minus R2 will cancel. By R1 plus R2. R1 by R2 ka root. This is your answer. Similarly, V1 will be root 2GM by R1 plus R2. This will be reverse. R2 by R1 ka root.
Sir,
Hmm.
sir, the simplicity is R2 minus R1 upon R1 plus R2.
हाँ देखते हैं ना पहले ये क्लियर है
Yes.
Have a look at this, everyone. This is the velocities in terms of R1 and R2. Clear? So once you got this, what is the second part you want? Aerial velocity. What is aerial velocity? dA by dt is L by 2m. So what is the angular momentum? mvr. You can just take mv1 r1. So m into v1 is root 2 gm r1 plus r2 r2 by r1 to r1. So this is your angular momentum, right? So this guy will be 1 by root over gm by 2 r1 r2 by r1 plus r2. That's your aerial velocity. And what's the time period? 2 pi by root gm a to the power of 3 by 2. And what is a here? R1 plus R2 is 2a, semi-major axis. That's how we get the time period. And we also know time period is pi AB by aerial velocity. From here, you'll get beta value. That's the length of the semi-minor axis. You'll get everything from there. What about energy? Minus G M M by R1 plus half MV1 square. Take any one guy. This will be minus G M M by R1 plus R2. This is minus G M M by 2A. That is the energy of a satellite in an ellipse. All these are very important results.
So for potential, you took kinetic and potential energy differently then.
Yeah, just add them up. All getting the steps. It all starts with the conservation of angular momentum and conservation of energy. So this result is important. Huh? Energy of a satellite in elliptical orbits. I wrote it anyway here beforehand. This is the proof actually. You just need to substitute V1, V2 and you'll get it from there. And what about radius of curvature? Do you remember what is radius of curvature? So at this point here, when you're going in a circle, this is the radius of curvature. So the attraction force G M M by R1 square should be equal to M V square by R capital R1. Be careful, small r1 is not the radius of curvature. So radius of curvature at point A, so G M M by R1 square will be MV square by RA. If you substitute all the values here, you end up with RA will be, we get good values actually, 2R1 R2 by R1 plus R2, which will be also equal to RB because it is symmetry. That's the radius of curvature. What about eccentricity? For an ellipse, do you remember the coordinates?
A, 0 and 5.
This was AE, 0. That means this focus which is there now, this total distance will be how much? A plus AE. This distance will be how much? A minus AE. So ho gaya na. So A minus AE is R1. A plus AE is R2. Divide them. So 1 minus E by 1 plus E is R1 by R2. From there you can get eccentricity ka value. Clear?
Sir, sir, when finding that radius of curvature, we found out A and B. So from that we can find the equation of ellipse, then use R equal to 1 plus dy by dx.
कर ले ना. When I was stopping you, do it ना, finish it off. जब आंसर तुझे इतना एक स्टेप में आ रहा है, नहीं तुझे डिफरेंशिएशन करना है, कर लो. वो भी रूट में आएगा डिफरेंशिएशन. You're not wrong, but why to do so much? So this guy will be A minus R1 is AE. A is R2 minus A. If we divide them, divide नहीं करेंगे. Clear? Please have a look at this problem. It's a pretty good one. You can ask a lot of things from this: eccentricity, length of minor axis, blah, 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 everything. Clear? Next one. Last one. It's a good one. Last one in gravitation. Standard equation. Assume Earth is going in a circular orbit. It's actually a slight ellipse, but yeah. Then, if the Earth is suddenly stopped, so someone came and just caught the Earth, somehow it happened, and you just released it. You just stop the planet from rotating, meaning from revolving, and just you leave it again. So that means what will happen? Velocity becomes zero, right? So that means there's no centrifugal force to balance the gravitation. So it falls into the sun. So the question is, find the time taken for the Earth to fall into the sun. Yeah, everyone will fly off, but first let's do the problem and then we can make them fly. That I didn't ask you, whether people will fly, what will happen. The question is in how much time the Earth will go into the sun. So basically what is happening, right? This is sun. This guy is going in an orbit. So at any point of time, the attraction force G(m)m by r square was actually being balanced by the centrifugal force mv square by r. And then what you did, somehow the Earth was stopped for a moment. The Earth velocity suddenly became zero. Then what will happen? There's only a gravitational attraction G(m)m by r square that won't stop. Because of this, you'll go and crash into the sun. So how long will it take for the Earth to crash into the sun? How do you do this? This was a standard question. It came in the exams. It came in JEE also. It came in multiple entrance exams. Think for a minute. The idea is pretty weird, a little different one. You can't do it in a normal way, but using Kepler's law, we can solve. There's no need to integrate. कुछ करने का जरूरत नहीं है. Integration is actually a big mess. You can't solve. Think for a minute, then I'll show you. Let's see. Ritam, you're mad or what? Here I clearly wrote you, it is going in a straight line and you're asking me something else. You can't see, or what is the problem? The problem is you keep switching off the cam, right? You're busy doing something else. So I think you just listen to the class when it is convenient for you. Can you just keep your cam on? Let us see what you're doing so great. Yeah. Do keep your cam on and make sure I can see your full face. All I can see is the two eyes, like Batman types. Let's not do Batman. See what is happening. The idea in this problem is, so this was the sun and you are going in an orbit of radius r. Now, instead of making velocity suddenly zero, Imagine if you decrease the velocity by a small amount, what will happen? If velocity is decreased, then what will happen? Instead of going in a circle, this will start going in an ellipse. Agreed? If you're going slower, you'll go in an ellipse, but you'll go in a smaller orbit. If velocity is decreased, we observe the Earth goes in an ellipse, which is smaller. If you decrease still further, then what will happen? You'll start getting closer and closer to the sun. You'll still go around the sun, but you'll go in elliptical orbit, isn't it? As the speed is decreasing. Do you remember if the velocity is less than v orbital velocity, you go in an ellipse? So you're going in an ellipse. If you decrease the speed even a little more, then what will happen? You'll almost go into the ellipse. So as v tends to 0, we observe something interesting happens. As v tends to 0, we get an ellipse. Where the semi-minor axis b tends to 0. That is, it becomes a straight line. Do you agree? So velocity, if it is getting closer and closer to 0, the ellipse actually tends to become a straight line. So your diagram actually becomes like this. So when you're going velocity v, you're going in a circle. If your velocity is v0, you're kind of going like this. Fair enough? So for this thin ellipse, what is a minor axis, semi-major axis? This whole thing was r, no? Previously, this was 2r. Is this making sense? And we know from Kepler's third law, the time period t square is proportional to major axis ka cube, semi-major axis ka cube. So t1 square by t2 square. Initially, the semi-major axis was r. Now the major axis was r by 2. This will be 2 cube. So t1 by t2 will be 2 root 2. So t1 is the initial time, which is 365 days in a year. This is t2. But what is this t2 here? t2 is the time taken to complete one revolution. So this is the time taken for this entire ellipse. But we're interested only in the one-way journey, right? So time taken to go from, time taken to reach the sun, you won't come back again. Will be half of this. Which is 365 by 4 root 2. I think this thing approximately comes to 70 days, I guess. How much was that? 360. $65 days. Again, listen to the story, I'll tell you again. So what we are trying to do is, we are trying to make this into kind of an ellipse. So when you make V0, it will become a straight line, everyone agrees? But with a straight line, I can't do anything. So what I will say, instead of saying V is 0, you say V is very, very, very small, 0.00001. So what you get is an ellipse, which almost looks like a straight line. Fair enough? So for this ellipse, the major axis will be the radius. Initially, the major axis was 2r. Got it? So the final major axis was r. Initial major axis was 2r. And from Kepler's third law, we know t square is proportional to a cube. T1 is the initial time for the Earth to go in a one revolution. So this was 365 days. 1 year, the time taken for sun to go around the sun. So we get the time taken for the Earth to go from Earth to sun and back is T2, but we know only one part of the journey, so it is T2 by 2. Check it out. So this is how you can use Kepler's third law to figure it out.
Sir,
Hmm.
sir, can we do it with the integration? Sir, yeah, acceleration will be gm upon x square.
हाँ, करके मुझे working भेजो.
Okay.
Shaurya, I'll tell you one thing. When you have some brilliant ideas now, first you do it. You send me the working. After the class, we can sit and discuss.
Okay.
You get pretty excited, you know, in doing some weird things. The problem is I'm worried that you're not following up what we are doing. You're getting it? So कुछ ideas है, कुछ problem नहीं है. Try them. Discuss with me after the class. But first listen to what I'm teaching also. Right? Because आपका जो innovative ideas है ना, उससे you're not getting any marks in the test. So let's be very frank about it. Right, Shaurya? Yeah. Clear with this? So do that additional things. I'm really happy about it. But let's discuss about it after the class. Try करो. तो खुद try करके मुझे working भेजो. Don't tell me your ideas and don't throw your ideas on me. So what you want me to do? Sir, अभी integration है कर लो. You do the integration. You die. Nah, when you have an idea, you should try it on your own and then you should come for help. You don't get an idea and you don't throw it on the teacher and say, teacher, you do it now. This is my idea. But anyways, first listen to what I'm teaching also. Clear with this, everyone? There, with that, we're done with gravitation. So do finish off HCV. There are only 39 questions. Kepler's law was the only thing that is left over. But I hope you could see the difference, right? Other than satellites, most of the thing was same as electrostatics. So it resembles a lot. The next one. So we'll finish off Gauss laws and then we will do surface tension, viscosity, and elasticity. Gauss law chapter is actually kind of difficult in a way, because this is one of the rare chapter, you know, where numericals are less, the logic is more. There are numericals, but at least the starting part of the chapter, right, you have to solve a lot of problems because of logic and theory. So let's see, when we start, you'll understand. So that way it is a little tough, but if you got your basics right, it's manageable. Anyway, I'm going to show you so many different models so you'll get the hang of it. So Gauss law is a continuation of actual electrostatics. So the first thing we define is something called an electric flux. This word flux, right, we use it a lot. Again, it comes in magnetism. The symbol is phi. So what is flux? So this electric flux is simply proportional to number of field lines passing through an area. So everyone, you're not understanding something, please do ask. Huh? Don't think like, oh, sir is shouting, you should not ask. Oh, please ask. Don't mind me, between me and Shaurya, we have a different equation together. This Shaurya is actually using me like a, Kabhi, you know, did you do this thing when you're bored, you stand there, you take a ball and hit the wall, you're catching the ball. So for Shaurya, I'm that wall. He gets the ideas, he throws the ideas onto me and I keep bouncing back. So you please do ask. Actually with Shaurya also, I have no problem. Problem ye hai, wo innovative method mein na, he doesn't understand standard methods. So do ask. Don't hesitate. Yeah, today I was actually a little frustrated also with whatever happened. So let's see. Felt really bad. No, I'm not actually bad for the student also. I'm feeling sad for the mom and dad. Student is anyway idiot. कुछ नहीं कर सकते है ना. Mom and dad are feeling bad na. So see, flux is proportional to the number of field lines passing through an area. Please do it. Why I'm telling, understand. Next year it is our turn. You should be in a much better position. So flux is proportional to number of field lines passing through an area. If you remember, the field length itself is an hypothetical concept. So listen carefully. Chapter is not difficult if you got your theory points right. If you don't get the theory right, chapter will look a little weird. So if you have field lines passing like this, if you have field lines passing like this, or if you have field lines passing like this, meaning 5 are going this way, 6 are coming this way, we say all of them have same flux. So flux could be anything, okay? If you see the number of people crossing a road, flux. It's a human ka, people flux. If water is passing through a pipe, it is a water ka flux. So flux is simply any quantity that is passing through an area. So here, if you observe something, it does not depend on the area. It does not depend on the orientation. It depends only on how many lines are there. 1, 2, 3, 4, 5, 5, 6, minus 1, 5. Is this idea clear? So flux ka basic understanding is this. It's the number of lines. Clear. Now, if you go for a more technical definition, this is more of a theoretical definition of flux. The more of a technical definition of flux is given by integral E bar dot dA. E bar is your electric field. A bar is your area vector. If E bar is constant, E comes out of the integral. The flux ka formula becomes E bar dot A bar, which is mod E mod A cos theta. That means if you have an area here, so this would be your area vector. And if this was your electric field, the flux is EA cos theta. But did you see the irony of the situation? Just now I told you something. I said the flux does not depend on area and the angle, it depends on the number of lines. Suddenly I'm saying it will depend on field, area, and angle. What's happening? Where did I goof up? In just one page, I changed the whole story again. In the first page, I said it depends only on number of lines. Second page, I'm saying it depends on field, magnitude, area, and the angle. Anyone? What is electric field definition? Anyone remembers? Number of lines per unit area, right? So that area and this area will cancel. What do you get? Number of lines. Are you getting it? Field is nothing but number of lines per unit area. Area cancels out. So the catch is this. Electric field and number of lines are not same. Number of lines per unit area is field. So this is the catch there. So if you're studying flux in terms of field lines, if you study flux in terms of field lines, flux is independent of area and angle. If flux is studied in terms of electric field, then it depends. I think you guys need to put down this flux integral E dot dA. That's it. That is a basic concept of flux. Clear? Now, the main confusion here sometimes people get right is the area vector. How do you take area vector? For closed figures, outward normals are taken as positive. So if you have a sphere, so these will be the outward normals. For open surfaces, like a disk or something, we take the direction of the field as area vector direction. We try to keep the angles acute basically. Generally, we choose the towards Z bar. Whichever side is in the direction of this thing, we generally choose the direction of E bar. Clear how to take the directions? Let's see a question. That's it. Theory wise, that is the first part of the theory. Let's see some questions. So the only formula I taught you is, remember, E dot dA. So let's say we got a cube. X-axis, Y-axis, Z-axis. This is a cube of side A. So this is phase 1, phase 2, phase 3, phase 4, phase 5, and phase 6 is behind. So the question is, first one, the electric field in the region is E naught into I cap. E naught is constant. The electric field in the region is E naught x I cap. The electric field in the region is E naught xi cap, E naught yj cap, plus E naught zk cap. Find the flux through each phase. 3 different questions, 6 fluxes. So if the field is E naught I cap, find the flux through 1, 2, 3, 4, 5, 6. If field is E naught xi cap, find the flux through 1, 2, 3, 4, 5, 6, and so on. Should I help you with one? I'll show you the first one. See. So the field is going which way? Field is like this, E naught. Area vector is also like this. Here the field is this way. Here the field is this way. Field is this way. Field is this way, and field is this way. So if you look at the surfaces, here area vector is like this. Here area vector is behind. Here area vector is up. Here area vector is down. So similarly, here area vector is like this, and here area vector is like this. So here area vectors are actually perpendicular. So the face is now 1, 2, 3, 4, 5, and 6. So flux through 3, 4, 5, and 6 is 0. Why? The electric field is perpendicular to A bar. Flux through 1 will be minus E naught into area. Area is A square. Flux is a scalar quantity, people. There's no direction. Flux on 2 will be plus E naught into area. E naught A square. So flux to the total cube will be 0, because if you think about it logically, what is happening here? The amount of lines entering is equal to amount of lines leaving, right? If the field is uniform, if 100 lines are entering, 100 lines are leaving, so what's the total flux? 0. Understood how to do this? Now, can you try B and C? Try. I'll give you 2 minutes. So you just need to find the area vector, field on the surface, and multiply, and done.
So can you go on the next page? Yes, sir, thank you.
See, E naught x I cap. This is actually more easy than the previous one. So 1, 2, 3, 4, 5, 6. So we're talking about field is equal to E naught x I cap. So the flux in 3, 4, 5, and 6 is still 0, right? Because E is perpendicular to A bar. I agree, E is changing, but it is perpendicular. It doesn't matter. And on the first one here, field is 0 because x coordinate is 0. And here on this plane, x is equal to A. So field will be E naught into A I cap. Is that making sense? On this entire plate 2, x coordinate is constant, no? On the entire face, this face, the x coordinate is constant because it is parallel to that. So flux on 1 is 0 because E is 0. So flux on 2 will be simply E naught A into A square, E naught A cube. Please check. Is that making sense? Can you do the third one? E naught xi cap, E naught yj cap, E naught zk cap. Idea is the same. E naught xi cap, E naught yj cap, E naught zk cap. Try, I'll give you a minute. See now, if you think about this, did you observe one thing? For E naught x I cap, only the plate 2 got the field, right? E naught y, can you tell me who will have the field? 3, na? Y will have 0 coordinate for 4. E naught z के लिए 5, right? So basically, whoever is touching the origin, all will have 0. The other 3 plates only will have it. So for the third part, let's take like this thing. Flux due to the first plate, second plate, third, fourth, fifth, and sixth. So if you take due to E naught x I cap, this guy is 0. This guy is A naught A cube, 0, 0, 0, 0. If you take E naught y j cap, so the y coordinate is 0 only on 4, and 1, 2, 6, 5 will be perpendicular. So 0, 0, E naught A cube, 0, 0, 0. Is this making sense? Similarly, for E naught Z K cap, only plate 5 will have field, everyone else will be 0. Please check. There is a flux on each plate, so you can just add up all of them. Clear? Clear, Arushi, Ritam, Kavya, Danya, clear? Turning the page. Again, I'm just teaching you one formula, integral E dot dA. Next one. Next one is a good one. Listen to this carefully. Let's see how many of you can answer. So we got a hemisphere. And we have a uniform field E bar. And this radius is R. Find the flux passing through the curved surface. How do you do this? Any ideas?
So could we use the like projected area concept or something?
Shaurya, you are right. Rhythm got the answer. Shaurya, why are you not shouting now? Silent ho gaya. You are typing answers.
No, sir, I
right.
got it from that method that I will send you.
So see, you can use projected area, right? Do you remember starting flux ka definition? The number of lines passing through area, right? So if you have any random amoeba shape also like this, think about it. Every line that passes through this, let's make it a little simple. Every line that passes the curve will pass through the disk. Agreed? Since number of lines crossing the disk and the curved surface is same, flux is same, you can use projected area. Therefore, flux is same. So if you got something like this, and if you give me some random curve, it doesn't matter. You can just take this projected area and finish it off. But again, it works only for uniform field. Therefore, flux is equal to E into projected area. E has to be constant. Clear with this concept? So what is the answer here? The flux will be E into pi r square. So be careful with this, huh? Don't write like this. Flux is equal to E into 2 pi r square. This is wrong. You know why? Can someone tell me why that is wrong? Look at this. At every point, how is the area vector? This is the area vector, right? How is the field vector? Field is like this, now. How can you say E into dA? Theta changes at every point. You can't take theta of the integral. Theta changes at every point. Got it? Therefore, we can't do this. This is wrong. I hope this logic is clear. Just don't multiply E into surface area. That is wrong. You have to take the angles also. Here, theta is changing at every point. So flux will be integral E dA cos theta. Clear with this?
So we should do I cap, J cap, then do.
Yeah, then you have to do. वो सब करेंगे तो ये आएगा projected area. So remember this thing. Projected area is an important concept. So this is the second time it is coming. All clear with this? Great. Last one for the day. So we have a hollow sphere. We kept a charge q at the center. We kept the hollow sphere. We kept charge somewhere here, not at the center. Find flux passing through the sphere. Show you. First thing, see now, first one is easy. So if you keep the charge at the center, how is the field? Like this, no? Field is radial. How is the area vector? Area vector is also radial. So at every instant, E and A ka angle is same, 0. Isn't it? So basically, E bar is parallel to dA bar at every point. Therefore, flux will be integral E dA cos 0. E is anyway constant, so integral dA. What is integral dA? The surface area, right, of the sphere. What is the surface area of a sphere?
4 pi.
4 pi r square. Four pi epsilon r square into 4 pi r square. Q by epsilon. That's the flux. It's a good result. You need to remember this. How will you do for this guy? What if the charge is not at the center? Think for a minute. See, I'll tell you something. Suppose I draw a sphere. There's a charge q at the center, okay? These are the field lines. Clear? Suppose now, if I take any surface like this, random, like this amoeba shape. So this is surface 2 and this is surface 1. Can you comment something about the flux? Same, right? The flux through the curved surface is same as flux through the sphere because the same number of lines pass. And we proved for a sphere, flux is q by epsilon. Therefore, flux for any closed surface, doesn't matter which shape you take, is the charge inside by epsilon. Is that making sense? Got the logic? So it doesn't matter actually which kind of surface you take, because what you will tell me, you'll take, sir, I'll take a random surface like this. Charge q is here, find the flux. You know what I will do? I will draw a circle with the charge q at the center. I can always draw a circle with the charge q at the center. And I know the flux that is passing through this will be q by epsilon. And the same number of lines will pass through the curved surface also. Making sense? This is actually Gauss law. Whatever we proved now with Coulomb's law is actually Gauss law. So we will discuss more about this in the next class. So technically speaking, Coulomb's law is more powerful than Gauss law. But Gauss law is prominent because it came before Coulomb's. And plus, it is pretty useful to study, right? Whenever you have a symmetrical charge distributions, Gauss law works wonders. But if there are point charges and all, Coulomb's law is always superior. So what is that? We will see that in the next class. So next class will be more theoretical. We will be doing more concept-based problems. Like, did you see how did we solve this problem? We didn't calculate anything because the number of lines are same, flux is same. You know, chapter mein half of the questions are like that. It is always about statement se prove karna padega. Okay, so we'll wrap up.